But what I want to do is build a watertight cylinder for a submarine, and I want to put a piston on either end. Then I want to mount with each piston a distance sensor, so that I know exactly where the piston is on either end of the cylinder. And I'm also going to add to it, as I've done with my other boats, a pressure gauge. And between those three things and an arduino, I want to be able to control this submarine really well. Alright, so I'm going to break this down into 5 stages. This is a major project. The first stage is to build the inserts and the components for the watertight cylinders, build the pistons, build the bulkheads and a joiner. Going to get all of that done in the very first part. Then we need to build the gearboxes that are going to drive the pistons. And that is really the bulk of the next 3-4 videos, where we work all the way through that process. And I've got to say, I think it's pretty good, because bearing in mind we're scratch builders, we have to have processes in place so that we can do things accurately. And it's all about being logical and iterative. And I'm really quite proud of these videos, because they set in place a process. Obviously you need a lathe, but they set in place a process where you end up with something that's pretty successful, and it's not expensive. The final video of this group is where we put the piston together and we run it and we see how it goes. Stage 1, that's the build. Of course, I'm actually building 2 pistons at the same time, but that's another story. Stage 2, we get the piston obviously going, and then I'm going to use the laser sensor and the Arduino, and I'm going to build, to begin with, a script in the Arduino which will read the RC. I want to read 3 channels. One channel to move the piston, the other channel to take a snapshot of the pressure at the sweet spot of what will be neutral buoyancy, and then the third channel to control the dive and surface routines. We can do that very simply, so that's stage 2. Then we go to stage 3, which is getting 2 pistons and getting them to work together, adding the pressure gauge and getting the diving routine to work. So we'll layer that in so that at the end of that time we have on the bench all of the electronics working for this piston system done, and the trimming process as well, which is going to be very interesting. And then the 4th stage is getting a WTC, a watertight cylinder, cutting it up, building all the stuff into it. It'll have everything other than the motors which go behind this particular system. So we'll get all of that done, and we'll test it in a pool, and we'll show how it works, obviously without a submarine attached to it, and we'll see whether it works 2 meters down, how it's all going to go, whether the motors for the pistons are powerful enough, all that sort of stuff, and how the routines work, which is very exciting. Then comes stage 5, and this is dependent on my getting from somewhere an empty sub and being able to fit it into a sub and put the motors in and get the whole thing working. And I've got to say, it's a great. This is going to be a great series of videos. Let's go. Alright, so here are my raw materials. I've got some, I think it's about 22mm plastic, some 10mm plastic, some 6mm acrylic that I'm going to use to make the bulkheads. And I've just drawn them out, a little bit oversized, and now just using my cutter here to cut them all. And this does a remarkable job even with the thick material. This is going to be a very interesting process, and I've thought a fair bit about how to do this and what the best way of doing it is when you've got a small lathe. And I think this is practically foolproof. I can't believe that this tiny blade does this so well, but it does. There we are, back to normal speed now. and these are going to be the pieces I'm going to use for the pistons. I'm a bit concerned about how thick they are. I'm not sure that they're going to be all that effective. What I'm going to do now though is just make a piece of brass, tap it out nice and squarely right through the middle, and this is going to be a mandrel which is going to enable me to work on all of these pieces far better in the lathe. It's always worth doing a little bit of preparation before you do something like this. I'm using 6mm stainless thread, and that's going to be the material that's going to work with the pistons. So the trick now is just to put a point in the center of all of these items that I have built, and the next thing that I'm going to want to do is simply drill them all. Start off with a center drill. It's the best way of doing this. Then putting a drill through, which is good for cutting a thread, and I put it through all of them. And now I'm going to use the drill press, interesting technique here, to put this thread through each of them. Now you're probably wondering why I'm threading them all. This is going to make sense as we go along. And I must admit, it really has been a bit of a winner of a process, not only for mounting in the lathe, but also for lining up the gearboxes. And you'll see that when we get to it. So I just want these threads nice and square, running through the middle of all of these pieces. Okay, there we go. Now I'm going to use a piece of thread and my mandrel and a couple of nuts on here. And this is now what I'm going to put onto use to mount these pistons onto the lathe. That's it. Happy with that. Needs to be nice and tight. The trick, of course, with this is never to take a bite that's too deep when you're using the lathe, because that's as it's just on there with the power of the thread and the bolts. Now you can see that washes out of line, but in fact the bolt is nicely in line, and I've used my dial gauge to get that perfectly right, so that I can now begin to machine the outside size down. If you've seen me make pistons before, you'll be fully aware of the process here. I machine that down until I get a nice sliding fit, and it's not ready yet with this. And I'm just taking, a couple of, maybe 1 or 2 thou off per cut at this point. It's a bit like angel hair here, just to get it to the point where I get this really nice sliding fit, because now I can use my cutter to cut the groove for that O-ring practically perfectly. And once I've done that, then I can trim down the plastic of the piston a bit, because I don't need that to be even a firm sliding fit. It can be quite loose, as you can see here. But the O-ring needs to be nice. So I've got the first one done. In practice, I discover that this is still a bit too tight, and I'm going to have to trim it back. But you can see, even with a glass of beer, we're coming along quite well, and we're now going to do the next piston. And yes, we go through the same process. This all went without a hitch. Now I've got this thick piece, I think this is 22mm, and this is going to be the piece that sits in the middle of my finished cylinders, so that I can pull them apart in the middle. There's another purpose behind that. There's going to be wires coming out of this little thing, and they're going to come out through this. So I'm just developing the right thickness on both sides. You can see I've nearly finished that now, and that's a very, very nice fit. I'm very happy with that. That's going to be pretty good in the middle. So I'm now also making the bulkheads out of acrylic, and we're going to glue those in, or actually weld them in. I'm now taking the center out of that centerpiece, And here it is. Here are all of the parts that I want for my cylinders. Pretty happy with that.